Hey there, and welcome to our second video for our Unit 6 Test Mastery, our sinusoidal modeling. Last time we started with the worksheet on our application for sinusoidal functions. We did number 2 together. Today, or I guess now, whatever, this time period, we're going to do number 3. Alright, so number 3, we have this pet store clerk, and he's noticing that the population in the gerbil habitat varied sinusoidally, whatever. With respect to time in days, he collected data, graphed his result, and then we got to figure out basically what this thing looks like. Create an equation. All right, so if this is my data, my graph, I'm going to hold it up a little bit more so we can see it there. I'm going to try and find some points on this graph. It looks like my y-axis is going up by 1s, and my x-axis is also going up by 1s. So we're going to need some data points here. I'm going to call this x min, y min, and then I'm going to call this x max, y max. All right? So on my graph, I'm going to sketch this out. We have something that looks like this. All right. So for this one here, it looks like that happens at 3, 2. And then my maximum value for my function happens at, they're going to make me work for this here. All right. It looks like that's happening at 17. And then 32. Because who wants nice numbers? And then over here, this is happening at 31 and again at 2. I'm happy that it's the same min value, otherwise we'd have some issues, wouldn't we? Okay, so based on this function, we'll do the same things we did last time. There are just some basic things we got to figure out. We're going to have to figure out amplitude. We're going to need to figure out our b value. Let me just write my function again. So I'm going to do population of x. That's going to be a times my cosine value of my b value, x minus h plus, well, let's close that grouping symbol, plus k. So amplitude, let's find this a value. Amplitude, we're going to take our midline, and then amplitude is from the midline to the top of the crest, or from the midline to the bottom of that curve. The easiest way for me to do this is to say, I'm going to take my y max and find the distance between my y max and my y min, and then I'm going to divide that thing by 2. All right, so I'm going to go, what is this? So 32 minus 2 over 2. I probably shouldn't have used a calculator. All right, my amplitude is 15. There's my a value. Done. Okay, let's talk about that b value. That b value is going to be 2 pi over your period every single time. Okay, period is how long this thing takes to repeat itself. Looks like that's happening here. So from 31 to 30, I guess from 3 to 31 is the period. So I'm going to do 31 minus 3. That's 2 pi over, what is it, 28? All right, you may leave your b value as 2 pi over 28. People would understand that. And in fact, there are arguments for leaving it that way. That way you can actually see your period right away. I think most people are comfortable with just reducing it to pi over 14. Okay, let's take a look at our next one, phase shift. So amplitude, b value. Let's go phase shift. Your phase shift is your h value. And again, this is the whole reason that we only use cosine when we're doing modeling, or that I only use cosine when I'm modeling, is because instead of trying to do I don't know, fit a sine curve to this thing, there's all sorts of weird ways to do it. This y max value is always going to end up being our phase shift. So this distance is your h value. So from 0 all the way out to, it looks like 17, that's what we got. So it is always going to be the x associated with your y max. So for us, that's just 17. All right, last one, midline. The midline is your K value. That's this value here. So we already found amplitude. So you could do either 32 minus amplitude, or you could do this 2 value plus your amplitude. I'm just going to take Y max, Y min, average them. So let me show you that down here. So we're going to go K. My midline is Y max plus Y min. I know there's lots of different ways to do this. We're just going to, I just reached for a calculator and I realized that these numbers are really, really nice. So let's just do that. It looks like we're at 17. Let's just check. 2 plus 15 is 17. 32 minus 17, 15. Oh, this kind of works. I'm sorry, it's 32 minus 15 is 17. This is my y equals 17 line. I misspoke there. Okay, there's my K value. Let's throw all this stuff together, shall we? Here's my function. Population of gerbils based on the day is 15 times my cosine value of pi over 14 x minus, I just lost it, phase shift, 17. There's a whole lot of 17s in this problem, isn't there? Okay. And there we go. I hope that was helpful. Have a lovely day.